Hey guys, we are going to work on practice sheet 29. I am going to start with you on number 1, but you are going to finish this out. So for find the area of a composite shape, we want to break it into the shapes that we see. So when I'm looking at this based on my numbers here, I'm seeing a triangle, one triangle, and a semicircle. Okay. You might see 2 triangles. The reason I'm not going to put 2 triangles is because I have this entire distance, okay? So when we're doing this, remember, you find each area and you add it. So triangle, go to my formula chart. A equals half BH. And then remember for circle, we only have a whole circle. We do not have semicircle, okay? So that means we will find the area of the entire circle, but then we divide by 2, okay? So I'm going to draw this right here so that you do not forget. That's going to be your job. So I'm going to find this area. Once you find the triangle, put that in here. Find the semicircle, put it in here. And then, guys, remember you add those because we want the combined area, okay? So I'm going to help you plug in. You're going to do the math. So half, get my triangle base. The entire base is 10 times the height of 11, okay? I want you to solve that by yourself. Okay, then over here we have pi r squared. Remember, pi comes from our formula chart right down here. Some of you like to call that something else, but it is pi. Pi is 3.14. That's what we use to estimate it as. Remember, pi is irrational. It's the only irrational number we use in 7th grade. All the other numbers we know are rational. Okay? So now I need the radius. Well, I'm looking right here. I know that whole distance, guys, that's the diameter, right? The diameter is 10. Make sure you label that every single time that you work with a circle, label whether you know the radius or diameter. So for this problem, I want the radius. So remember, the radius only goes to the center. Okay, so that means we're not going to use 10. We use half of 10, which is the radius. Half of 10, 5, and we square it, okay? So 5 squared, remember that means 5 times 5. Okay, this is where I'm going to leave you. You need to multiply 3.14 times 25. Remember on the second row to hold your spot, okay? Now, once you get that answer, you need to remember that you have to divide that by 2 because it's a semicircle, okay? Once you have this number and this number, then you add those 2 pieces, okay? So I'm leaving you with the arithmetic to do. Multiply here, put it here. Multiply here, put it here, divide by 2 because it's half. Add those 2 numbers. Carefully make sure you've lined up your decimals. Okay, number 2 is simplify. I'm not going to explain how to simplify. You know how to simplify. We divide the top and bottom by the same number until we cannot get it anymore. We cannot get it any lower, and our numbers that are on top will be whole numbers, okay? No decimals. Solve here. I'm not going to explain because you know how to solve an equation. Just please watch your integer values. If they're negative, you make sure you grid the negative. If it's positive, you don't have to, but you can. It's a good thing to do just to make sure that you are watching your sign. On number 4, guys, this one right here, this one can be a little tricky, okay? Which situation can be represented by this inequality? So the first thing that I notice is that my variable is basically on the wrong side. I do not like it that way. My brain does not work that way. So I am going to flip it. I'm going to make sure it's pointing at the 120. So I have to flip my sign, okay? Now, remember when you have a number next to a variable, we're looking for per, each, every, okay? So I want to see 12 with the word per, each, every. If I see per, each, every with 29, I know that is not a correct answer, okay? This comes from STAR. You're going to see something like this. Please have a strategy ready, okay? Felicia has 12 buttons in her collection. She will collect 29 new buttons every year. So right now when I look at this, I'm thinking, okay, she has 12 and she's getting 29 more every year. So I'm thinking with a Y. Felicia collects buttons for K years. So it's not Y, it's going to be K. But I am not going to go any further, okay? Because I know that K needs to be next to 12. That one is incorrect. I don't even have to read the rest of this. B, Felicia has 29 buttons in her collection. She will collect 12 new buttons every year. And remember, K stands for years. So far, these are very similar, very similar problems, guys. 29 buttons plus 12 buttons every year. So 12K. So that's basically the same thing here, okay? It's no different than 12 plus 29, 29 plus 12. Even though I can't combine these, it's just a commutative property there, okay? So, but you cannot combine 12 with 29 here because it's not 12, it's 12K. Okay, so it says, for what values of K will Felicia have at least 120? Guys, you have to know what this word at least means. It means that many or more. So basically it's saying, for what values of K will Felicia have 120 or more? 120 or more, okay? So this one looks good. I'm going to put a question mark by it. Felicia has 29 buttons in her collection. She will collect 12 new buttons every year. Ooh, this looks almost exactly the same, okay? So I'm saying 29 buttons, collecting 12 new buttons every year. Felicia collects buttons for K years. For what values of K will Felicia have at most 120? At most means it can be 120 or less, okay? Your problem needs to be 120 or less. And again, this can be kind of confusing. I'm going to put a question mark here because I'm not dealing with the inequality yet. I'm dealing with this part. D, Felicia has 12 buttons in her collection. She will collect 29 new buttons every year. So look here. She starts with 12. She collects 29 every year. So the good news is, I know I'm not going to go any further. That one is wrong, okay? So if nothing else, you have a 50-50 shot. So I'm going to go back to the verbiage and look at my sign. So basically, the end is the only thing that's different, okay? Felicia has 29 buttons in her collection. She will collect 12 new buttons every year. 29 buttons, she's collecting 12 buttons every year. Okay, she starts with 29, she's getting 12 every year. For what values of K will Felicia have at least 120 buttons? So she needs 120 or more. Okay, so this is saying it can equal 120, this can equal 120, or this can be more. This can be more. Remember, a lot of y'all think of that alligator thing that's eating the bigger one. This can be more. So this looks good. Okay. If I look at this one, it says, for what values of K will Felicia have at most 120? So at most 120, that means it cannot be bigger than 120. This here cannot be bigger. Well, that would be reversed. It could equal 120 because at most means it can be that, or it can be less. Okay, so this one is wrong. So you want to make sure, I mean, guys, that's very careful reading, but if nothing else, you have a 50-50 shot. I would flip this inequality. You don't have to. To me, it makes it easier. Number 5, I hope you can tell this is multiply and therefore a triangle problem.